Hi, my name is Dakota, and my project was over the water-gas shift reaction. So this is the equation for the reaction. So basically, it is carbon monoxide gas reacting with liquid water, and we get hydrogen gas and carbon dioxide gas. So this reaction was originally discovered in 1780 by an Italian physicist named Felice Fontana. And what is important about this reaction is that when the water vaporizes, it eventually produces the hydrogen. And as the hydrogen is being produced, the carbon monoxide is converting into carbon dioxide. So this reaction is industrially relevant, but it does not start off at the beginning as relevant as it would be later in the early 20th century. And if you were wondering what happened in the early 20th century that made the reaction important, it's it was the Haber-Bosch process. So basically, the Haber-Bosch process was the production of ammonia in the early 20th century. And so the water-gas shift process played a big role in it through hydrogen. Because if you remember, hydrogen is produced heavily during the reaction, and one of the elements used to make up ammonia is in fact hydrogen. So this was big because according to the New York State Department of Health, a lot of ammonia is used in fertilizer, about 80% of it. And in addition to that, ammonia can be found in household items like cleaning solutions and sprays for pesticides. So yeah, that was really big for the water gas shift reaction to be played in that process, because I feel like that's what kind of that was really important back then. Again, with the fertilizer, there's so much that is can be done. Fertilizer, you're growing plants, it's like a chain reaction. And then the last one is that the reaction is sensitive to temperature. So according to an online journal, Water Gas Shift Membrane Reactors, the authors explained that it is exothermic, and it can dictate and or even reverse reactions based on the temperature. So with that being said, a lower temperature is actually favorable over a higher temperature when it comes to the catalysts. And the authors also explain that the main role of the reaction is to increase the amount of hydrogen, so that way they can invest more into their big productions of industrial chemicals, again, like menthols, hydrocarbons, and again, ammonia, which is used for a lot. In conclusion, the water gas shift reaction was and still does play a big role in many ways, especially within the industrial production.